Hello and welcome to today's video, which is gonna be about, as you can see, the topic simplify to the basic form and express conditions, and it's really gonna be about expressions that contain the factorials, as we are in the topic or section about factorials. Let me give you just the first example we will be solving. So let's have the expression and factorial over n minus 3 factorial. As our task says, express the conditions. Let me first remind you what are the conditions, or when the factorial is defined. As we said during our previous video, factorial is multiplication of the numbers starting with n and going down to number 1, and we have proved that factorial, if n factorial is defined, that it is defined for all natural numbers including 0, which means n including 0 is the set containing numbers 0, 1, 2, 3 and so on and so forth. And we have proved that this is okay, include 0, because 0 factorial is equal to 1. Next thing, before we start solving or simplifying our given expressions, it is important to remind you and explain also some, let's say, tricky thing, that n factorial can be written as n times n minus 1 factorial, for example, which is also equal to n times n take away 1 times n take away 2 factorial, and so on and so forth. So, for example, n factorial can be also written as n times n take away 1 times n take away 2 times n take away 3 times n take away 4, and you can keep going, but the last expression will be, in this case, n minus 5 factorial. I have shown you in the previous video how this one works, but before we go on, I want to just explain, for example, if you have such an expression in factorial 3n plus, let's say, 2 factorial, how would you write it, like in general, for any given n, as the multiplication of, let's say, first 3 terms and then the factorial. Basically, what you do here is you always increase your number and as well expression in the parentheses by number 1. So you start with 3n plus 2 times, and now you just ask yourself 3n plus 2 take away 1, which means you just subtract number 1 from the previous number, what this expression is equal to, and I'm pretty sure you can see that this is gonna be equal 3 times n plus 1. So the next factor will be 3n, because if you take away 1 from this expression, you will get 3 times n, and times, if you take away again number 1 from this expression, it's gonna be 3n take away 1 factorial. Okay, so this is like the very first exercise, just to remind you how the things work. And I also wanted to show you, for example, in this expression, that if you would say to yourself that, for example, n is equal to 5, then what would it mean? You evaluate the expression on the left side, which is gonna be 3 times 5 is 15 plus 2 is 17 factorial. So this expression for n being equal 5 represents 17 factorial, which is equal to, without calculating the values of each expression here, you already know that this must be equal to the multiplication of these numbers, and as we have 1, 2, 3, so we should finish at the fourth, so this is 14 factorial. So let's prove this for our expression. As we already calculated, 3 times 5 plus 2 is 17 factorial is equal 3 times 5 plus 2 is 17 times 3 times 5 is 15 plus 1 is 16 times 3 times 5 is 15 times 3 times 5 is 15, take away 1 is 14 factorial. So everything fits. Okay. I'm pretty sure everything is clear and ready for our task to simplify our first expression and express the conditions. So first of all, let's start with the conditions, which means in this case that we have two factorials, so the first factorial n must be greater or equal to 0, as this is the condition where our factorials are defined, and as we are in the denominator, the factorial n take away 3 is defined if and only if expression n take away 3 is greater or equal to 0, which sorry, I said and, but I wrote or, and n take away 3 is greater or equal to 0. So in this case n must be greater or equal to number 3. As both of these conditions must be true, there is the only one, because n is greater than 0 includes also 0 and 1 and 2, but the second condition doesn't allow us to use these numbers, so the final condition is n is greater or equal to 3. As we have the conditions, we can start simplifying this expression. We will use again something we already I already reminded you, which means n factorial, and if you have a look at this one, you can probably see already, but if not, then this is the thing of training and simplifying couple of expressions. You can see that the first factorial in the numerator of our fraction can be written like this, times, and here it is really a good idea to stop factoring and use the factorial instead, because now I'm pretty sure you can see that n minus 3 factorial in the numerator and denominator, they will cancel each other, so our expression is now simplified. And if you want to play around, I will write the result of the multiplication of these three expressions. You should probably try it by your own and find out that this multiplication, which is n times n minus 1 times n minus 2, is really equal to n cubed minus 3n squared plus 2. Okay, so you try by your own and just check with this answer. Okay, let's go to the next example, which is gonna be again something very easy. N factorial over n times n minus 1 factorial is equal to, probably there are a couple of students who already can see that the result is 1. I'll show you in a minute why and how, but before we start to simplifying this expression, it is important to write the conditions, and as n factorial should be is defined for n being greater or equal to 0, and n minus 1 factorial is defined for the expression being greater or equal to 0, but as the expression is given this way, there is one important thing: n cannot be equal to 0 in this situation, because then it would be mean 0 in the denominator, and this is the problem, because fractions are not defined for denominators being equal to 0. So from these two conditions it is quite clear that n is greater or equal to 1, but this is good news, because this condition cancels also the condition that n cannot be equal to 0, so this is our final condition. And now let's simplify the expression. There are like two ways how to come to number 1. I will show you the first, which we are used to, n factorial as n is greater number than n take away 1. I think this is clear, because if n is 5, then this is gonna be 5 factorial and this is gonna be 4 factorial. So we simplify the numerator of our fraction to the expression n times n take away 1 factorial over n times n take away 1 factorial. So now you can see you can cancel all expressions from numerator and denominator, and also as numerator is the same as the denominator, it is quite clear and obvious that this is equal to 1. Okay, the next approach may be for advanced, let's say kind of advanced users. You can probably see that this expression really represents the same as n factorial, and again the same situation, numerator and denominator are the same expressions, or you can cancel each other, and then it is quite clear that it's equal to 1. Okay, let's go to kind of more sophisticated example, and let me just show you how to calculate this one. N plus 3 factorial over n plus 1 factorial times n plus 2 squared. Okay, as you can see in this expression we have factorials as well, the expression being squared. Before we start, let's define the conditions. Let me write it in this case here. So the first condition is n plus 3 is greater or equal to 0, and n plus 1 is greater or equal to 0. And I want to stop here and say something for the future conditions, or for expressing the future or next conditions. If you realize that this inequality tells me that n must be greater or equal to 0, and this inequality tells me that n must be greater or equal to 1, if you have something like this, I guess you probably realized that it is enough if you take the expression of the factorial that represents the smallest factorial, so in this case n plus 1, because if n is greater than 1, it includes numbers 2, 3 and so on and so forth, so it is really not needed to take n plus 1 factorial in mind. It is enough if you think about the biggest factorial that occurs in your expression. Okay, I will remind you in the next exercise as well. So from these two conditions it is true that n must be greater or equal to 3, but be careful, we have another expression here, and this expression can be equal to 0. So we have to find out or solve the equation n plus 2 squared shouldn't be equal to 0, but you should already be familiar with this one, which means n cannot be equal to -2, because this is true if and only if n is equal to -2, but this is also again out of our condition here. So if we say n must be greater or equal to 3, all the conditions are met, and for such numbers this expression is defined. So let's go finally and let's solve this expression, simplify. Now the smallest factorial is n plus 1, so again n plus 3 factorial can be simplified to n plus 3 times n plus 2 times n plus 1 factorial, good news, over n plus 1 factorial times n plus 2 squared. As you can see, the factorials will cancel each other, and now maybe you already see, yeah, you already see, so I'm sorry, I'm gonna do it right here, right now. N plus 2 squared means n plus 2 times n plus 2, so it can cancel one n plus 2 expression in the numerator, and our final result is n plus 3 over n plus 2. Done. Okay. Now let's go to something which is a little bit more complex, and then I'll try to solve like really tricky exercise. So the next one could be this one. Okay, n plus 1 factorial, take away n times n factorial over n minus 1 factorial. As I said in the previous example, it is enough to define the condition for n plus 1 must be greater or equal to 0, because it says n must be greater or equal to -1. Okay, n factorial says that it must be greater or equal to 0, and the last factorial n, oh, I made a mistake in the previous example. Okay. Okay, I'll fix it in this example, and then I'll fix it in the previous one. So n, the last expression is n minus 1 must be greater or equal to 0. So here everything is clear. From this expression n must be greater or equal to 1. So the final condition is n is greater or equal to 1. As I said in the previous example, I'm sorry for that, this was a mistake, but as you can see, it is okay. Everybody makes mistakes from time to time. I said that it is enough to say the greatest number of factorial or expression that represent the greatest number, and just think about this one. But the mistake I made here is that from this expression or from this inequality, the true story is that n is greater or equal to -3, and from this inequality is true that n is greater or equal to -1. So basically -1 is greater than -3, so this one is not correct. The correct condition is that n must be greater or equal to -1. So it is true that you just take the factorial or the expression of the factorial that represents the smaller or smallest number in this case. In this case, the smallest number is n take away 1, which is this part of the condition. And as you can see, if n is greater than 1, definitely this condition is met, and definitely also this condition is met. So our final condition is n is greater or equal to 1. Sorry for the mistake. So now what is the clever idea here, as we have more than one factorial here, to find what is the smallest, which expression represents the smallest natural number, and in this case is again n take away 1. So the first factorial can be written n plus 1 times n times n minus 1 factorial minus n times n times n minus 1 factorial over n minus 1 factorial. Okay, so let me just color these three common factorials. I will show you now how to simplify this, but maybe some of you already know that this is possible to cancel like this, and then you will get just the final expression in the numerator. But let me just explain. So as both terms in the expression in the numerator of our fraction have in common n take away 1 factorial, you can put it out of the parentheses, and then it remains from in the parentheses from the first expression n times n plus 1 minus n squared, okay, over n minus 1 factorial. What basically means that you can cancel n plus n take away 1 factorials, and you can simplify the expression in the numerator, but this is not gonna be fraction anymore, and it's gonna be n squared plus n take away n squared, which is definitely equal to n. Okay, I think probably that it is really enough, and the video is already 20 minutes long, so I'll write for you like 2 examples or 2 exercises with the results, and you can try by your own. They're a little bit more tricky, but more you train, more professional you come. So this is like the first exercise you can try. N+1 factorial over n minus 1 factorial. But on the other side, if you will not be able to solve it, or you would need kind of explanation how, and so just write me the comment under this video. The result of this scary expression is very simple. It is number 2, and I'll give you one more like advanced expression. Minus n plus 2 factorial over n plus 1 factorial take away n minus 1 factorial over n minus 3 factorial, and this one should be equal to 9 times n plus 8. So that's all for today, for today's video, and I will be happy if you find this video helpful, and I hope we see each other during our next video. Thanks for watching. Bye bye.